Hello, everyone. Thanks for the introduction, then. Hope you can all see me and hear me fine. So I'm Alex Kyriakiris. This is how you will pronounce this. And I wrote the first book on Vue.js back in 2016 because I wanted to help developers learn this awesome and new framework and make their lives easier. And it's quite amazing thinking where we are now and with everything starting from just a book. So from there, I founded BitterBrains in order to continue supporting developers worldwide. I want to welcome you all today to another Vue.js Nation, which is the largest Vue.js conference in the world. This is the fourth year we are hosting this event, and we have over 6,000 people joining us today. We're welcoming people from 140 countries or more, with people also from hundreds of companies joining us worldwide, including some very big names like eBay, Apple, Verizon, Oracle, Disney Plus, and many more, which is always fascinating seeing how many big companies that sometimes we know, sometimes we don't, that they use Vue.js or they care about Vue.js to an extent, and they're going to be part of our communities. Vue.js is again free for another year. We managed to keep it this way and follow our mission of making education accessible around the world. And for this, I want to thank you, all of our amazing customers who support us and enable us to make this happen. At BitterBrains today, we make developers' lives easier with accessible education, with credible certification, and community events. Our educational products include Vue School, the #1 source for Vue.js education, where most of you are members in a way or another. And it's like the products and the items we run now at BitterBrains, they get so many that I struggle to fit in one slide. I put quite some time and yeah, sorry for the certification pile. So yeah, it has been interesting how we started from the Vue stuff and we are expanding in all of the other networks, and we grow together with the needs of the development industry. So in education, on top of Vue School, we run the Mastering Nuxt platform, which is the official course for learning the Nuxt framework, and we build this in partnership with the Nuxt team. And we also have our latest course platform, Mastering Pinia, that we developed with the creator of the Pinia library and Vue.js core team member, who is also the creator of the video course that we host there. And as of 2023, we also help developers grow your skills and career opportunities with credible certification programs that we have developed fully in-house. We have made our own technology, both for preparing for the exams, getting bootcamps, getting async training, and whatever developers need to prepare and learn everything for a specific technology. And then we have our own assessment platform, where we have code challenging, bug fixing problems, along with typical, multiple choice questions and stuff like that. So we invested a lot to make this platform because we wanted, we had some specific items and we had a very specific approach of how we think developers learn and how developers can perform and showcase your skills. And we are very happy with where we are today. We have received really good feedback from the Vue.js certification program, which was the first certificate that we developed in partnership with Evan Yu. Like, Evan helped us put together really good content. He reviewed all of the challenges and assessments we have there. And after we developed the full platform for Vue.js, we decided to expand it to the certificates.dev system in order to help more developers benefit from improving your skills and also getting better career opportunities. So now certificates dev has expanded to both supporting Nuxt, JavaScript, and Angular, which we are doing in partnership with some Angular partners. And we plan to continue expanding and supporting more developers and more businesses on this front. And of course, at BitterBrains, we also host some of the largest online events in the industry, including Vue Nation, Frontend Nation, and Next Nation. Today, I can share an update on where we stand with some of our flagship projects and what we plan to do in the foreseeable future. Vue School, with new lessons releasing every single week for years, has reached an impressive amount of 1,424 lessons spread in 72 courses on all of the things Vue.js in the ecosystem, which are all developed by some of the greatest Vue experts and core team members. As usual, we also completed a few months ago the Vue.js masterclass. That is a completely remake of the course. We use the latest Vue.js framework, the latest patterns, and everything from the ecosystem to remake this course for I think that was the third time that we built the course, and now it's fully complete, and it covers everything a developer needs to build like full stack Vue.js applications with best practices and whatnot. Next, in Mastering Next, we're currently working on remaking the course with Next 4. Michael Thyssen has already started working on this, and we're going to ideally to launch Mastering Next 4 content together with the Next 4 release when this happens. On the Mastering Pinia front, the course is now 100% complete. Now, for the certification side, we have delivered all of the content for all of the levels for the Vue certificate and the Angular certificate, and this is a massive milestone for us. And we're currently working on completing the Next and JavaScript certifications. We have right now available the mid-level, everything for preparation and examination for both certificates, and we're working on finishing and releasing the senior levels in the next couple of months. Another exciting milestone is on our new Instant Dev product that we announced a few months ago, and we already completed the pilot. If you don't know, Instant Dev is the platform where businesses and startups work with our teams in order to get production-ready code done for their applications. So it's like a dev team extension. So we completed the first pilot with a couple of businesses. We optimized our processes and delivery functions, and we are currently accepting new businesses in the waiting list. Some more news on what to expect soon from us, from BitterBrains. Later this year, we plan to release a completely new design for the Vue School platform. We want to release an upgraded UI and UX. We already moved a lot of things from our Laravel and Play templates like last year to use Next 3 and Vue 3. So now most of the platform is a complete SPA. We plan to complete this and then have a new like user experience to support our users learning and navigating through the hundreds of lessons and a lot of topics that we have nowadays. We're also working on expanding and refactoring the Mastering Next platform to become multi-course. So we want to have a couple of specialized courses that are already in the works to expand from like a single masterclass structure to having the masterclass and have accompanying modules and allow users to take like learning paths based on what they need to do and how advanced they need to get with Next. Next on certificates dev, we're preparing our TypeScript and React certificates, which are the ones who are requested the most from our community on the platform. And if you're interested in these certificates, or if there are other technologies or other frameworks that you would like to train and get certified on, you can vote directly on the homepage of certificates.dev. You can see we have a poll in the bottom with frameworks and technologies like front-end, back-end, and you can put in your vote. And we analyze this data, and based on what our audience needs, we decide which technologies to cover next. We're super excited with TypeScript. It's been very popular and requested by all sorts of developers worldwide. And lastly, we have been working on AI content for web developers specifically. and we want to help you stay ahead of the curve. We want to help you be super productive with all of the cool stuff happening in AI. And yeah, we also want to help developers enjoy coding more and get most of the repetitive tasks or like things that can supercharge your productivity done for you by the bots. And Daniel Kelly will present a new exciting talk here at Vue Nation later today on how you can build Vue.js applications using multiple AI tools. And if you're interested in this type of content, you can sign up to get notified when we release our first hot AI courses on vue.school/AI. I love this URL sorter. And with all of our products and events at Bitterbrains combined, we managed to support over 2 million developers worldwide, which is a number that grows every year. And our audiences include also developers from thousands of large and popular companies, like some of the ones the ones I list here. And many of them also prefer to train and certify their Vue devs with us instead of using enterprise providers, which is something that makes us really, really proud for telling for nowadays that enterprises don't just go to the equivalent providers, but they're open to using startups and new and more modern tools. Now, to develop and support all of this and the new products, we run a team of 31 full-time members, and we also work with industry-leading advisors. This includes people like Alan, who is a Google developer expert on Angular and is leading our certification front. Sebastian, the creator of Next, who is supporting us on the official Next certificate, as well as with courses on mastering Next. And of course, Evan Yu, creator of Vue and Vite, who is reviewing all of the content for the Vue.js certificate exams. And he also participates in the JavaScript certificate to help us make sure our content is top-notch. I want to close with our most exciting news. And as you might have heard, at Bitterbrains, we are currently raising funding to grow faster, develop more products, improve our platforms, and support even more developers worldwide. And before we explore VC or other avenues of funding, we decided to give the opportunity to our friends, family, and everyone in the community to be the first to buy a stake in the business. So for a limited time, everyone can invest in Bitterbrains to support our mission and to benefit from potential financial gains in the future. And if you're interested in this, you can find more information about our raise, but also you can find some nitty-gritty details about our business on our campaign page on republic.com/bitterbrains. That's it from me. Thank you all for joining us, and hope you have an amazing experience here at the conference.
Thank you, Alex. We do have a couple questions for you. Really quick. The first one, how has the Vue community evolved since you first started Vue School and became involved with it?
Okay, that's an interesting one. So yeah, when I started with the Vue community, it was still forming. There was not even like a Vue core team back in the day. Like in the first days of Vue.js, it was only Evan Yu who was developing the framework, and then later he made a Google form to get people interested to be part of the to develop this Vue.js core team and expand the ecosystem. And at the same time, there was a lot of things happening like constantly in the Vue.js community. We had the first in-person conference in Poland. Then this was like maybe a couple of hundred people joining. Then Vue Amsterdam happened in 2018, which was like a huge celebration for Vue.js developers. I think it had close to like 800 or more people, and it was really amazing seeing how this grows. We had the Vue Jobs website like being released and merged also with other Vue Jobs. In the beginning, it was two different websites that they merged together, and constantly we would see more people developing content. We will saw people like releasing books, having a lot of course providers, and a lot of tools coming from the open source community also. Like nowadays, like there's like hundreds, if not thousands, of Vue.js libraries and plugins, and yeah, it all started from like being something very small that today is being used, like a framework being used by millions of developers worldwide. So yeah, it was like a really like a fun journey, and very interesting to see it growing from small to the massive framework it is today.
Thank you. And our last question is, how do you see AI tools impacting Vue development?
Mm, I think it will make the AI tools will make Vue development more fun. Like in general, I see AI tools as a framework for web developers. So similar to how when we had vanilla JavaScript, and then we had jQuery, and then we had frameworks like React and Vue, and every time we have a framework, we cannot see, like, look back and imagine working, like, for example, making full, like, big applications with vanilla JavaScript. I think it will be the same with the AI tools. Like very soon, we will be using, like, in the Vue development, a lot of utilities that it will, like, write code for us. It will make our testing. It will create boilerplate. It will, create, like, our components, things that we need, and we will be able to code, like, 10 times faster, and it will look funny not using any AI tools and doing everything like manually to an extent.
Awesome. Thank you, Alex, and thanks for starting Vue School and Better Brains and all of this. We're excited to see how it continues.
Awesome. And yeah, nice to see you again, Jen. Thanks for the presentation. I'm looking forward to watching everything today and tomorrow.
Thank you. All right, y'all, quick video, and then we'll be on to Evan.
Hey folks, this is just a sneak peek into the treasure trove at viewschool.io, your go-to for over 70 top-notch courses on Vue.js, Nuxt, TypeScript, and more, all developed by industry experts. From Pina and Vue Router to upcoming features in Nuxt 4, we have got you covered. Start with the basics or dive into advanced topics like performance hacks, AI with GPT-4, and even web scraping. For Vue.js Nation only, grab 50% off yearly or lifetime plans. Head to viewschool.io/plans today. Don't wait.
All right, y'all. I know that majority of you definitely know who Evan Yu is. Will be joining us to preview Vue 3.6 and Vapor Mode. Evan Yu is an independent software developer currently based in Singapore and the creator of the JavaScript framework Vue.js and the front-end build of the tool Vite. Welcome to the stage, Evan.
Hello. Hello, everyone. Great to be here again. Hello from Singapore. So apology in advance. I caught a cold a few days ago, so my throat is still very itchy, so I might have to cough from time to time. But still excited to be here and to share with you the progress and the planning and a preview of the upcoming Vue 3.6. Okay, so let's get started. So a high-level overview of what's coming in Vue 3.6. The first, foremost, and most important thing is a massive reactivity performance improvement. We'll dig into each of these a little bit later, but here, so first, the reactivity improvements. Second, Vapor Mode, as many of you have been waiting for. And there will be some major internal types improvements. And finally, suspense stabilization. Okay, so for the reactivity performance improvements, many of you probably have remembered that every past minor version that we shipped, starting with Vue 3.4 and 3.5, we kept improving the reactivity system in Vue because fundamentally it is at the heart of Vue. In recent years, we also have seen a trend of not just Vue, but most other front-end frameworks that is not React have pretty much arrived at the consensus that Vue's reactivity model, which is fundamentally the same thing as the concept as known as signals, is actually an ideal paradigm for front-end development, and it aligns with our mental model really well. So it helps a lot in describing the declarative state relationship in front-end UI. So Vue's reactivity system has a long history. It has pretty much stayed with the same internal concept since Vue 1, right? So in Vue 2, there was some re-implementation, but Vue 3 was the first time it got a major refactor. So in Vue 3, we started shipping proxy-based reactivity, but proxy-based reactivity, i.e. the deep objects, are actually built on top of the lower level primitives, i.e. refs, shadow refs, computed, and effects, reactive effects, right? So if you have looked into the Vue reactivity package, you will notice that there is ref, computed, and effect. These are the three most important primitives of a reactivity system. And in fact, it is most of the other reactivity-based frameworks like Solid.js, Svelte 5, even Angular nowadays, all the Preact signals, all these frameworks and libraries that ship with the concept signals actually has the exact same primitives, maybe with slightly different implementations or APIs, right? So this is also the reason why at TC39 there is actually an initiative about standardizing signals as part of the language, right? So for signals to actually be standardized in the language, still there is a long way to go. So it's probably not going to happen in the next few years. It will take multiple years for this kind of things to eventually reach stage 4 and eventually get implemented by browsers natively, which by that time will likely have the best possible performance. And then we can maybe refactor Vue's reactivity system on top of it. But before that happens, right, there is still plenty of room for us to squeeze out possible performance in this aspect. So Alien Signals by Johnson, who is also the maintainer of Volar and Vue language tools, is an implementation. It started as an experimentation by trying to figure out the best possible performance for Johnson's own use in his projects. But turns out you were able to he was able to actually develop Alien Signals into a version that is able to cover most of the use cases that's needed in the official, not only in the official signals part of it, but also cover the needs of Vue. And he spent tons of work making sure porting Alien Signals into Vue core can pass all Vue ecosystem CI tests. So this is no small feat. And Johnson was able to keep improving Alien Signals while making sure the ported version in Vue into Vue actually can pass all Vue's related tests. So the first PR that got merged was 12349. And it was porting Alien Signals 0.4.4. So by the time we merged it, it already showed minus 14% memory usage compared to Vue 3.5, which is the branch you're currently probably using. And it shows massive improvements across multiple benchmarks. So this is the graph around the time we merged that PR. So at the top, you can see Alien Signals. And you can also see many other interesting implementations in the ecosystem. You probably didn't know there are so many different signals implementations. And Vue's reactivity system in 3.5 turns out wasn't actually the fastest. And Alien Signals is faster by a great margin. And TC39 Signals Spotify is performing pretty bad in this case. So which is why Johnson actually later on implemented a signals polyfill based on Alien Signals to help with the standardization process. But turns out he wasn't done yet. Right? So Johnson kept on improving Alien Signals since So 0.4.4 was the point where we first merged into Vue's development branch, the minor development branch for 3.6. So it is not live in production in 3.5 yet, right? So with every release, alien signals got faster and faster. So in alien signals 0.6, we found another 13.4 performance improvement and 3.4 reduction in memory usage over 0.4.8. And again, so a few weeks later, alien signals 1.0 brings another 12% improvement over 0.6. So Johnson has spent countless hours doing micro optimizations, comparing different techniques, different ways of instantiating objects, trying to save memory, save bytes, save computation. So so eventually, when we merge the alien signals 1.0 into Vue's development branch, and we can compare this across a big benchmark. So the purple bar, so the text is probably too small to see, but the purple bar is alien signals, and the green bars is Vue 3.4. And so here we're showing alien signals as the baseline of 1.0, and Vue 3.4 is the higher the bar is, the more slower it is compared to alien signals. So you can see it is considerably slower compared to alien signals in almost every benchmark. But note this is 3.4. So 3.5 performs slightly better than 3.4, but still compared to alien signals, it's still a massive upgrade. So we're happy to announce that alien signals 1.0 has been ported and landed in the Vue 3.6 branch, which is the minor branch on GitHub, in the PR 12570. So if you're interested, do check it out. And also check out alien signals, the base library. So we decided that we are going to essentially duplicate the core logic of alien signals in Vue core at Vue/reactivity, so that we're not coupled to the release schedule of alien signals as a standalone project, which also gives us more freedom and flexibility to fix Vue specific issues in case we find other incompatibilities down the road. But alien signals is also available as a standalone library that's not coupled to Vue, and actually gives you the capability to define your own reactivity API surface, which is very interesting. And we hope that alien signals becoming the there is a potential for alien signals to become a foundation of cross framework signal implementation, because it is able to offer the best performance while supporting the signals polyfill. So technically, it should be able to fulfill the needs of most frameworks when it comes to a reactivity primitive. So Johnson is doing really important work here, and huge shout out to him for helping us advance in this space. Okay, now vapor mode. So first, a quick recap for those who are not familiar with the concept of vapor mode. Vapor mode is a new compilation strategy for Vue. So the core idea is you write the same source code, but Vue compiler will compile it to different compilation output, something that's more efficient, which means with the same API, with everything you've already learned, you get better performance and less memory usage, with nothing new to learn, really. So vapor mode allows Vue's rendering performance to reach the level of Solid.js, which is known for having probably the best rendering performance among all well-known frameworks nowadays. And it is also, most importantly, compatible with existing code bases. So it allows you to perform piecemeal migration or opt-in selectively opt into vapor mode only for the parts that are performance sensitive in your application. So when it comes to vapor mode, it is important to think from a high-level perspective because it is essentially the next step of Vue's rendering strategy evolution. If we look at how Vue evolved over time, during the times of Vue 1, we actually used a DOM-based templating strategy where we will take a string template, instantiate it as inner HTML, essentially create real DOM nodes out of it. Then we will walk that real DOM tree to find the bindings as actual attributes, and then create reactive bindings on the actual DOM nodes. So this is how Vue 1 worked. In Vue 2, we opted into pure virtual DOM. So the compiler will take the template and compile it into virtual DOM render functions. And then we ship a runtime, a virtual DOM runtime that is able to compare and diff the virtual DOM trees, right? So the reason we opted into virtual DOM was mostly because it was the most straightforward way for us to also achieve server-side rendering, which was one major new feature in Vue 2.0. But as later on, many have realized, virtual DOM actually adds quite a bit of overhead in terms of memory pressure and the cost of diffing. So it doesn't always lead to the best rendering performance. So in 3.0, due to compatibility concerns, we still shipped with virtual DOM, but we used the compiler a bit more to enhance it. So Vue 3, most notably, shipped with a much more powerful compiler, which allows us to perform more static analysis during the compilation phase to generate a code that performs better at runtime. So this allows us to essentially fine-tune the generated code, the generated virtual DOM render functions. For example, we can leave compile time hints. We can generate what we call virtual DOM blocks. We can generate vnode patch flags, which essentially are hints that's left for the runtime to take fast paths. So this approach allows Vue 3's virtual DOM to actually perform significantly better than Vue 2's pure virtual DOM. However, there's also a limitation to how far it can go with virtual DOM optimization, because regardless, you still need to create tons of virtual nodes, and that creates memory pressure. And you still need to walk through the virtual DOM tree, although you can skip over some of them. There is a limit to how much you can optimize in this direction. Moreover, because of these fast path hints, it makes our compiler more complicated because we are always thinking about. It also makes the runtime more complicated because we're always thinking about two code paths. One code path is the pure virtual DOM code path, which can be non-optimized case or manually written render functions. So this is less performant, but the logic is more straightforward. The fast code path usually depends on compiler-generated hints, but it's a different code path. So we essentially always have to think about, is this in the current patch phase, are we in optimized mode or non-optimized mode? This creates tons of complexity for the runtime. A lot of extra code needed, which cannot be tree shaken. It also leads to potential pitfalls, more bugs due to optimization. So there's definitely downside of this approach too. So vapor mode is essentially trying to get rid of virtual DOM altogether. Instead, we try to generate code that aligns with the possible code, most optimal code that you would have written by hand. For example, if the template describes a button containing a piece of dynamic text, right? So if we were to write this, render this interface using imperative APIs, we would say, well, create a button, then set its text. So if the text comes from a dynamic ref, we will use a watch effect to essentially set that text so that whenever the text changes again, we will set the text again. So this is how we would think about it if we were to write the API or write the code ourselves imperatively. And that is, in fact, exactly the type of code that vapor mode tries to generate. So it tries to generate code that essentially is the most direct way of achieving the result you want to see on the screen, while leveraging Vue's current reactivity APIs. So there is another talk tomorrow by our team member, Little Sound, Rizumu, and she's going to be doing a whole talk that's more focused on the philosophy and some compilation details of vapor mode. So make sure you tune into that. So vapor mode currently, the development, previously we had a separate repository called Vue Vapor, which was largely under development because we want to separate in the early phase of it, we want to separate the pull requests and issue lists from the main repo, just so there's less noise and allow faster iteration. But we've got to a point where majority of core features has largely been done. So we feel it's time to move the development back into Vue core so that we can integrate better into the same repository's infrastructure and CI pipelines. So the latest Vapor mode development is now happening in the core repo under the Vapor branch. And there is an open PR in case you want to see the changes, the diffs. It's a massive PR. There are hundreds of commits in that PR, and there's still tons of work to do. But if you're interested, check it out, and we're welcoming any sort of participation and contribution if you're interested. So in December, in the past December, we did another big push on Vapor mode. So this time we focused mostly on the component model, which was a part that was not very well optimized in the previous implementation. So essentially, we redesigned the component prop slots handling to make it initialize lazily. So this vastly improved component instantiation cost, which is another aspect of Vapor mode, right? So the compilation strategy itself makes the updates inside each component itself extremely efficient and fast. However, when we create a huge application, another aspect of cost comes from creating component instances. This is one area that we always wanted to improve in Vue. And Vapor mode gives us an opportunity to rethink how it works. In Virtual DOM, it is really hard to change the way props works now because there are too many implicit behavior depending on how props are tracked when components are updated. But in Vapor mode, we have changed all the props passed to child components to be lazily accessed, which means when you pass a prop into a child component, it is passing as a thunk, which is a function returning the actual value. So if you're passing a ref value down into a component, the ref value is actually not accessed until the child component renders itself. So this makes that ref the dependency of the child component, which actually makes the whole update graph more accurate. So when you mutate that ref in the parent component, only the child component updates. This might be a bit abstract, but we will come up with some more detailed examples to help you understand when we are closer to release. But to put it in easier to understand terms, component instances in Vapor mode are much cheaper to instantiate. And in a benchmark, we are able to mount 10,000 components. Just checking if the number is correct. Actually, it is, sorry, it is actually 100,000 components. I need to edit it right now. Underestimated our performance. 100,000 components mounted in 100 milliseconds. That's how efficient it is. So another big part of the refactor is we refactored the whole Vapor mode implementation to use a shared current instance between VDOM and Vapor. So there will be virtual DOM component instances and Vapor instances in the same tree because that is the goal. We want to allow per component update, which means the most common use case will probably be a Vapor to have a virtual DOM based application running mostly virtual DOM components, but you can have Vapor components taken over a subtree of it for in cases where it's extreme performance sensitive. Or you can have a whole Vapor component application that is Vapor only. But we also want to allow Vapor components to contain VDOM components. So in theory, eventually there might be a mixed virtual DOM and Vapor component trees, which means they need to be able to share the same. So the concept here is there are many utilities in the Vue core code base, like lifecycle APIs, providing inject, prompts validation, error handling. They don't really care if a component instance is virtual DOM based or Vapor based. And they should be able to work across the component graph, that a component tree with mixed instance types. So essentially, this is exactly what this big refactor achieved is now all these internal APIs work on a shared type called a generic component instance. And so you can use the same unmounted hook API in virtual DOM components or in Vapor components. They work the same way. Same for error handling, providing inject and props validation, etc. And finally, we also added HMR support, so that you get the same nice development experience when you're working in Vapor mode. So there are still a lot of things we need to finish, but in 3.6, we want to ship Vapor mode in a way where people can start using it without going through complex setup configurations. So essentially, the experience will be like, upgrade to Vue 3.6, nothing changes in your application. But now, if you take a component and change script setup to script Vapor, that component will be compiled in Vapor mode. Alternatively, if you start a brand new project with Vue 2.6, you can create your root app with create Vapor app, which will create an application instance which assumes to be Vapor only. So apps created this way doesn't pull in any code from the virtual DOM renderer, the virtual DOM runtime. So it will result in much smaller bundler size. To clarify, if you have a virtual DOM based app today and you opt into Vapor mode, the total bundle size will get slightly bigger because you're pulling additional Vapor runtime code. But due to the refactor we did, Vapor is able to reuse a lot of logic with runtime core. So the size increase will be very negligible. So probably around something like 3 to 4 kilobytes. There are features that will not be supported when we ship Vapor in 3.6. That is SSR hydration, transition, keep alive, and suspense. So we will complete this in future minors as we improve Vapor. But the most important thing is we want to get Vapor into the hands of developers, let people start playing around with it, and help us find issues, stabilize it over time. So then there are the internal type improvements. So right now, Johnson, again, is working on a simpler implementation for the define component type, which is the single most complex type in the entire Vue code base. If you've never touched the Vue source code, you probably don't really know what this entails, but I would recommend you go to GitHub, clone the code, and just search for define component type and look how many lines of types that is. There are like 5 overloads. Each of them are leading into more generic types with dozens of generic arguments. So it's a beast. And Johnson is working on trying to simplify it. And the significance of this is a simpler defined component type may be able to help us improve Vue type checking performance. Because when you use the Vue language tools, every code completion and type inference you see when you're using Vue SFC with language tools has to go through defined component. So the performance of this type can be can have a large impact on the overall type checking performance, especially in large projects. So to sum up, 3.6 will bring Vue's performance to another level. because thanks to adding signals, Vue 3.6 will have an S-tier reactivity system. Thanks to Vapor Mode, it will have an S-tier rendering system. So, and reactivity and rendering combined together is essentially the whole framework. So the whole framework actually gets a huge boost in terms of performance, while also allowing for smaller bundle size. So if you're using Create Vapor mode, Create Vapor app to create a Vapor only app, you will have a project with less than 10 KB baseline size. Okay, so that is Vue 3.6. I'm not sure how much time I have left. But I can quickly go through a few other important ecosystem updates outside of Vue itself, because people probably are interested in what we've been working on at Voice 0. So, Rowdown. We shipped Rowdown 1.0 beta again in December, and really encourage people, especially if you have existing projects that's using Rollup or ES-Build, Rowdown can actually now serve as a capable replacement of both. So Rowdown's performance, when we this is bundling 19,000 modules with 10,000 React.js components and 9,000 plain.js files. As you can see, we are not even comparing against any JS bundlers at this point. We're only comparing with ES-Build, which is written in Go, and Farm and RS-Build, which are written in Rust. And we are at least 3 times as fast as other Rust bundlers, and significantly faster than the ES-Build. But this benchmark was taken on a Linux machine with many cores. On Mac, it seems we're usually on similar performance with ES-Build, most of the time slightly faster. But another important thing is Rowdown has amazing WebAssembly build performance. So this is important when we do things in browser environments. For example, in web containers, aka also, which means like web containers. So not just in custom web containers tutorials or online IDE environments, but as an example, StackBlitz probably is the most well-known example of online IDE that's using web containers. Right? Rowdown running in StackBlitz environment is able to bundle 2.5 thousand modules in 0.6 seconds. And surprisingly, ES-Build, which is known for being fast, actually has a problematic WASM build that performs even worse than JS bundlers. So this is significant because when we get Rowdown into Vite itself, all Vite builds inside StackBlitz will also become significantly faster, which means when you use Bolt New, the AI service that's based on StackBlitz, right, all the projects will also scaffold and build blazing fast. Another area of improvement is the OXC minifier. So for a very long time, the minifier was in a prototype state, but Boschan has been working on actually making the minifier complete in the past month, and we're making great progress. As you can see in this benchmark compressing Three.js, OXC is able to achieve very close proximity compared to Tensor and SWC, just 1% difference in terms of compression ratio, better compression ratio than ES-Build, and the fastest performance among all of them, which is more than 5 times faster than SWC, which is also written in Rust. So this will also be the built-in minifier for Rowdown. So the performance will be amazing when we actually land this. So Rowdown Vite progress. An overview of the test cases. So Vite's own test suite using Rowdown is pretty much all passing. The 3 failing cases are all really edge cases, and we know how to fix them, but they're just not prioritized because these are really very few people will actually be affected by these. So we're focusing on the ecosystem CI right now. So we have 11 out of 28 tests passing, with 5 additional passing with minor issues. 9 failing. 6 of them we already know where the problem is, and we're working on those. And 3 skip because they're failing on Vue's own ecosystem CI too. So our goal for the next coming 2 months is to get as many of these ecosystem CI tests passing so that we can ship a version of Rowdown Vue into the hands of our users to test it out in real-world projects. Okay, so beyond ecosystem CI compatibility, the Rowdown Vue roadmap includes full bundle mode, which addresses the dev server startup performance issues with HMR and incremental build. And we're also working on module federation, which is a requested feature by many people who are stuck on Webpack. And we also intend to use Rowdown to power environment APIs to replace the current SSR transform, which is JS-based, which should greatly improve the performance in full-stack apps during development, because now the server-side graph will be handled by Rust instead of a JS transform. And also, there will be no more SSR externals problems, because everything can be just bundled, because Rowdown is that fast. So check out our latest roadmap here in the link. It is in the Rowdown discussions issue 153 to keep updated on the latest progress. And that's it. Thank you.
Splendid. Thank you, Evan. All right. We do have a few questions for you to get started. Which kinds of applications need a better, more performant reactivity system than we have now?
So think, for example, if you are building a, say, trading dashboard for high-frequency trading, and you have tons of data flushing in every couple hundred milliseconds, and your interface have hundreds of nodes that's constantly updating all the time. In this case, the memory pressure and overall performance of the reactivity system becomes a bottleneck. And also, there will be so in terms of reactivity performance, usually it is true that in your day-to-day applications, it will probably never be the bottleneck. So usually these are more extreme cases where you have, for example, some of the benchmarks tests extreme depth, like hundreds of chain computed properties, or extreme width, where a single computed property have thousands of dependencies. These are usually the cases where things may go wrong. You may not encounter them, but in the real world, we have seen many cases like that. Yeah.
Thank you. All right. What's the current state of Vue 3? How long to mount so many components?
I think current Vue 3 takes 250. So Vapor essentially, actually more than that, probably around 300 milliseconds. So Vapor mounts the components almost 3 times as fast compared to current Vue 3. Also, current Vue 3 mounting it actually scales with the number of props you have per component. So the more props you have per component, the slower the mounting gets. So in Vapor, because it's lazily initialized, so if all props are used up front, it probably doesn't make too much difference. But if you have a component, for example, a library component that has like 12 props, and you only pass like 2 to 3 of them, well, Vapor will be able to essentially only pay the cost of the 3 props you actually used and initialize the component much faster.
Thank you. Okay. What migration considerations should developers keep in mind for Vue 3.6?
Well, if you're not using Vapor, then there's really nothing to worry about. It's just a minor version. So there's no breaking changes. We don't plan to ship anything that would require you to manually upgrade anything.
Great. Okay. Is there any feature currently missing on a TypeScript level for Vue? I remember that defined props has some strange TypeScript behavior with null and undefined.
Yeah, so fundamentally, when you use defined props with the type declaration right now our implementation is that we actually parse the TypeScript types and try to reverse infer the runtime type based on your type declarations, right? So we wrote a pretty complex system to do that. It is able to handle most of the common types you would write, but it breaks down if you use really, really advanced types like map types with conditionals or generics, or you're importing a generated type from a library. So in those cases, the inference will probably break and will let you know, like, okay, you need to use a simpler type. That is one of the limitations that we eventually want to hope to fix. But the status quo is essentially a pragmatic trade-off that we decided to make.
Thank you. Will JSX be supported in Vapor mode?
Yes. So this is planned, and there is actually a version of this that's working by Gao Fei, who is a team member of the language tools. So he has a prototype of this working. We haven't really. I think at one point we will need to ship this as an official Babel plugin. It is implemented as a Babel plugin, unfortunately. So we currently have an official JSX Babel plugin, and we will need a version of that that's for Vapor mode. But yes, it is possible because we designed Vapor to be this way. So there is an intermediate representation, which is so the compiler parses the same template into ASTs. Then Vapor compiler will convert the AST into an intermediate representation, which then can be generated into JavaScript code. So the JSX plugin will essentially take the JSX source code, transform it with Babel, using Babel to transform that into the same intermediate representation, then hand it over to the Vue compiler for code generation. So the architecture was actually designed with JSX usage in mind.
Very cool. When will Vapor go out of beta?
So in terms of stability, for the features that we have currently implemented, I think that can actually be relatively soon. I think maybe a few months. The features that once we ship 3.6 and get people to test the features we've already implemented, I think it will only take a few months for those to be considered stable. But for the features that we haven't implemented, some of the more challenging ones, especially SSR hydration, will probably be the one that will take a while. Transition and keep alive. I think transition and keep alive are relatively easy. It's just we never prioritize those up to this point. And the most challenging one will probably be suspense support inside Vapor. But so when we talk about beta status of Vapor, we like to sort of separate the concept between feature completeness and stability. Right? So there are features in Vapor that we have completed, and at one point those features will be stable, and you can safely use those. But there will be, as we started, and we've been very clear from the beginning that Vapor will likely be a subset of the main Vue features. So any feature that we have implemented in Vapor will be compatible and will be stable eventually. But there might be features that we consider not suitable for Vapor to implement, and likely we will leave it out. Right? So the concept of Vapor stability and Vapor feature completeness, we like to kind of separate these two concepts.
Smart. All right, two more. So will there be changes to the current define component function in TSX to avoid specifying props as the second argument?
Well, this I cannot really answer you right now because we'll have to wait for the refactor to finish to have a definitive answer for that.
All right, last question. Will the release of Bun 1.3 it is a bundler, how does it compare to roll down?
Well, Bond has always had a bundler. It's essentially a direct port of ES Build in Zig. Bund's bundler is also extremely fast, but its feature set is essentially that of ES Build, which means it lacks plugin compatibility with Vite ecosystem. It doesn't have the advanced features that we're working on. For example, the HMR, the advanced chunk splitting, module federation. So it is not suitable for production bundling use as of yet. So in other words, Rowdown is essentially built to cover all the things that you already have in Vite plus additional features. Whereas Bun's bundler is with the scope of ES Build, which doesn't even cover the current scope of Vite.
Great. Thank you so much. That was our last question today. So thank you for joining us once again, Evan.
Thank you.
All right, y'all. Before we go to break, quick information about the Vue cert. As we just heard, Evan Yu has checked every single code challenge and multiple choice question for both mid-level and senior exams. Incredible dedication to the official Vue.js certification and the wider Vue.js organization. For just the event, we are offering the Vue certification for up to 50% off. And do not forget to use the code Certify50 to get the extra $50 off. So definitely use that code. And up next, we have break. So see you back shortly.